G'day there, you're watching the Aussie BIM Guru. Today I've got a tutorial that covers one of my least favourite tasks to do in architecture, and that is dimensioning. It's such a boring task and it's really such a waste of your life if you don't automate this task. I've had a lot of requests in the past to show you how you can use Dynamo in order to automate dimensions. And the key to this is getting the references of elements and then using some custom nodes from the package Genius Loci. So you will need this to run this particular tutorial. Now my goal here is to give you the framework to build upon. I'm not going to solve every single dimensioning problem you may have in Revit. I'm just showing you the basic concept of how it works, using a simple example of finding a grid near a column and dimensioning it in two directions from a horizontal and a vertical grid. So please don't ask me to make 50 types of videos on dimensioning. They're all different, but definitely make sure you check out the custom package to see what's available as options for how you can dimension elements. Anyway, I hope this is a really useful starting point. I'll be using Revit 2020.2.3 today and Dynamo 2.3 that comes with it. But a lot of versions can do this because the Genius Loci package works in other versions as well. Anyway, let's get started. So before we dive straight into Dynamo, it's important to understand what we're actually doing, what sort of elements we're dealing with. So in this case, we're dealing with column families, and we're going to be dimensioning them based on two references. So the concept of references is really important here. We're not going to be dimensioning geometry, we're actually dimensioning the reference planes inside the families themselves. So typically when you dimension an element in Revit, most of the time you'll be dimensioning a reference. And this is actually not necessarily a limited element in its extent. As you know, when you put a dimension on an element, it can be associated to the element from a long distance. And this is because it's all handled using a referencing system. So we're going to be working predominantly with the center left right reference plane and also the center front back reference plane of each of these objects in this workflow. The Genius Loci package is going to give us access to a lot of nodes that deal with creating references. Now in this case, I'm just going to dimension one grid intersection relative to all these columns, but you could refer to another one of my videos where I show you how to collect the nearest grids to an element using a different workflow to expand upon this further. In this case, I am just going to get rid of all these dimensions and I'm going to go into Dynamo. So to begin with in this workflow, we are just going to get all of those elements we want to dimension. I'm just going to select them all manually in this case, but you could of course select them using something like an element in view collector, but just to save time, I'm just going to pick them all using a select model elements node. From here, I am going to be using some nodes from the Genius Loci package. So I'm just going to have a look firstly for family instance references. And I might need to potentially type it in differently. I'm just going to search for reference and then go to the area in the custom package that we're dealing with. So if I find one of the nodes, there we go. You can see there's heaps of nodes that the Genius Loci developer has built for these types of purposes. In this case, we really care about family instance references. And we're just going to use this node here. So once I connect this in, we're going to get sublists for each of the references. So in this case, we can see we have two references collected for each column, and we can see the names of them as well. And finally, the plane or the point where that reference occurs. So it's important to understand that you're not always going to be just dealing with, say, two references. You might need to isolate these based on their name. So what I'm going to do is build a code block, and I'm going to build a list with two elements in there, the two references that I care about. Firstly, I'm going to look for center. And in this case, it's going to be left, right. And of course, you need to make sure that your name aligns perfectly, otherwise it won't find a match. And then we're going to use center, front, back. So the reason I'm doing them in this order is the left-right plane is the vertical plane and the front-back plane is the horizontal plane in regards to the grids I'll be referencing these dimensions to. So with this, we're going to find out from the list of reference names where it occurs. So I need to, in this case, use a list index node or an index of node. So I'm going to take my reference names and my elements. Now we have a sublist of names and a sublist of reference names as well. So what I'm going to do is set these both to level 2 so that for each reference, I'm going to look through each element and find that match. And I'm also going to have to set this to longest lacing. And now we should get the indices for our 4 elements. And of course, they're all going to be at 0 and 1 because we only have 2 references we're dealing with. But if you had many of them, this would return the index of where that occurs. We can then use this with a getItem@index node to retrieve the corresponding reference to that index. And again, we're going to work across sublists. So we're working at level 2. And we can see now that we get the corresponding references per element per those 2 references we want to collect. I'm then going to transpose these. So I'm going to swap the rows on the columns so that in the first list of the result, we now have all the vertical references. And in the second list, we have all the horizontal references instead. I'm going to make a code block, and I'm just going to say vertical or vert equals, and I'll just say L for list at index 0. I'm going to say horizontal is L at index 1. So this is going to let us split these into 2 different pathways that we can use later on. Now the node that we're going to try and get to by the end of this is going to require these to be paired up with the grid that we want the reference to relate to. So again, we're going to need to turn these into pairs. So the next thing we're going to do is actually go back a step, and we're going to start dealing with our grids. So in this case, I'm just going to manually select the grids that I'm dealing with using a select model element node. So first of all, I'm just going to do my vertical grid. So I'll just call this V and H. I'm going to select my vertical grid, and I'm going to select my horizontal grid. I'm then going to, in this case, have to get the curve of each grid, so the line that represents the grid itself. So I'm going to use grid curve, and I'll just look for grid. And there we go, grid curve. And we're going to get that underlying curve that represents both of those grids. And now if I go to my view, I can see that I've retrieved both of those elements. Now we also need the reference of those grids as well. So I'm going to look for, I might even be able to find it in here. No, I can't. So I'm going to look for reference again. And I'm just going to find that section in Genius Loci by clicking on reference. And in this case, we need the grid reference. So we're going to use the element reference in this case, because a grid is an element in this case. And it only has one reference. Essentially, the grid is its own reference. And we're going to get the reference of both of these. Now you won't be able to see them. They're just a reference element. From here, we need to actually get the location of each of our columns. So to do this, I'm going to use the, I'll do the element location node, but I might need to do get location. I think that's what it's called when you search for it. Yep. So I'm going to take my original columns, and these are going to be represented as points. Not every element in Revit is represented by a point. For example, a wall. If you do walls, you might need to use things like wall layer or wall edge references. So it's always going to be different depending on what you're dimensioning. I'm then going to find the closest point on those grid lines to the points of the grid. And this is going to allow me to form a line which is going to represent where the dimension is placed. So first of all, I'm going to be taking my curve and my point, and I can see now I've got the closest point on the vertical grid to all 4 of those references. Likewise, I can also now take my other grid curve and find those other 4 points. With these, I can create lines to represent where the grid segment is going to be placed. So in this case, I'll connect the start and the end, and I can now see that I have the horizontal grid dimension line, and I can do the same for the vertical as well. Now, at the moment, we may not always want our grid dimension line to be exactly placed on this line. We might want to offset it a little bit to put it away from the element that we are dimensioning. So I am in this case going to move these elements, and I'm going to use a translate node to do this. And I'm going to translate by direction and distance. So at the moment we're dealing with our horizontal dimensions. So we're going to want to offset these in the y-axis. So either up the page or down the page. So I'm going to get a y-axis node as well as the direction. And the distance will just be a number that the user nominates. For now, I'm just going to push these up in the positive direction by 300. And this will push my dimension lines upwards. Of course, if you want every dimension line to be different, you're going to have to build algorithms to handle this, and it will get pretty complicated. But in my case, I'm using quite a simple method. I'm also going to translate my other line, but in this case, I want to translate it along the x-axis. I'm going to create another number node, but in this case, I'm going to offset it in the negative direction to the left. And now this will give me the location where I want to potentially place my grid dimensions later on when we place the final dimension string. So we now have that element as well. And with this, I'm going to use the list join node just to join these together, because essentially these are going to represent each element in the vertical and then the horizontal direction in order. So I'm going to take my vertical first, because remember, even though we're moving horizontally in our dimension, we're dimensioning elements perpendicular to that, which is vertical. and then we're going to get our horizontal dimensions, and this will join them all at the same level. So now we just have 8 lines in the list. Now the next thing we need to do is we need to add the related grid references for each reference we've retrieved from our columns. So what we're going to do now is add an item to the front, and we're going to want to add, in this case, the grids to the front of each of those elements. So I want to use add item to front. I can't seem to find it yet. There we go. So in this case, to the front of the vertical elements, which we're going to work with at level 1, so each element, we're going to add, in this case, the sublist level of the grid reference. And what we'll end up with is a pair. So you're going to want to apply the longest lacing to this to do it for each element. And now we have pairs of references for each grid that matches each reference of the column parallel to it. Now you are going to need to make sure that you've definitely got the right reference. In this case, make sure that the reference you've retrieved is also vertical. And also we're going to do the same for our horizontal. But of course, we're going to go and get our reference from our horizontal grid instead. So now at this point, we've got nearly everything we need. We're also going to join these together, and we're going to want one pair for each line. So they're going to be sitting, sorry, I'll just copy this list join node instead. So these should just be sublist pairs. There we go. So now we have our 2 references, and now we can proceed forward to the final node, and we'll work backwards a little bit from here. But we're going to go to the dimension group in Genius Loci, and we're going to get a dimension by references. So note that you can have more than 2 references here. You can have as many as you want, as long as they're all parallel to each other, of course. But in this case, we do need our view. So in this case, I'm probably just going to take our active view. I'm going to take our current document. And I'm also going to take my active view. And it's pretty soon, we're probably going to stop working in automatic mode so that our dimensions don't get created. In fact, I might do that now. I'm going to go to manual mode. I'm going to connect my view, my lines, and my references. The last thing we need is our dimension type. Now it's up to you how you retrieve the dimension type you want. I usually recommend doing it based on a matching name, because probably you'll end up running this in something like Dynamo Player eventually. Okay, so in this case, I'm going to go and call on element types, because the dimension styles or dimension types are an element type. So I'm going to go and retrieve my dimension type, and I'm going to get all elements of element type. Now I have all my dimension styles. If I run this, I believe I might have accidentally no, that's okay, it's no problem. So I probably just need to make sure, maybe I'll keep this frozen for now. So in this case, I'm going to check the names of them. So I'm going to use element name just to have a look at what they're called, because we're going to find a match based on a naming match. So let's just say that we want to retrieve, in this case, the diagonal 2.5mm aerial style. So I'm going to I'll make a string actually, so the user could change it if they wanted to. I'm going to search for diagonal 2.5mm aerial. So we're going to check the index where that occurs. So you are going to have to find a match. This script won't work if you don't find a match. But from our list of names, we're going to say, where does that name occur? Which should give us an index of 0. So the first item in the list. From here, we can get an item at index. So from our list of original elements that generated those names, we find where that match occurred, and this will give us the corresponding dimension style, dimension type. I can then connect this to the dimension type input, and at this point our script is ready to be run except for one thing. We're going to want to run this on a longest lacing basis for each dimension style pair. I don't know if this is necessary. I believe that it was when I was trying to test this script, so I'm going to set this to longest lacing, and I'm going to unfreeze the final node, and let's just minimize our window and see what happens. So assuming everything has worked, I might just save this. I haven't saved yet. Let's just run, and we can see that now our dimensions have been created. And remember, we offset our dimensions in order to move them away from the elements, so we can see those offsets have been applied. And we can see that the reference pairs have been successful. So there we go, we've successfully dimensioned some elements. Now, obviously I've used quite a simple case to illustrate this. That you would obviously need to add a lot more to the script depending what you're dimensioning or how you're dimensioning it. For example, if you're trying to find the nearest grid pair, that's a little bit different, and I do recommend checking out some of my workflows on retrieving the closest grid references to an element in order to retrieve the corresponding grids you would need to match them to. Keep in mind you would need to do a little bit more complex list management back here in order to retrieve the relevant grids to the relevant elements. But otherwise it would be a very similar approach, especially if you're just using columns, which are obviously quite simple. There are other types of elements you can dimension in different ways, for example, the faces of walls. I would recommend definitely just having a look at all the references that GNS Loci offers you, because it really does manage to give you pretty much every relevant type of reference you would need. And remember that if you're dimensioning families, you do need to make sure that you've named your references so that they will appear in the original references list. But hopefully that helps you get started with learning how to dimension elements using Dynamo in Revit. So there we go. We found out how to automate a very boring task, and hopefully from here this gives you the ability to build your own types of dimensioning workflows. And remember that in this case I've only done a simple task, but you can build more complex algorithms and rules to determine how elements are dimensioned. All you really need is the references, and then from there the lines the dimensions belong to, and off you go. So look forward to seeing what people can do with this workflow and build upon. And of course, if you are looking for add-ins that do this, there are definitely add-ins out there. I'm putting one up on the screen now that I highly recommend. Again, most of these add-ins aren't free because they do save you time. They're productivity tools, but in this case, maybe rather than spending all this time building Dynamo scripts, you might find that this is a more cost-equitable way for you to work instead. Anyway, if you're not already following and subscribing, feel free to do so, and I look forward to seeing you in future videos where we'll automate more boring tasks that no one wants to do. Anyway, thanks. Take care. Bye.